Okay, welcome to another Ginger Mathematician video where I help you to improve your maths, your chess and your fitness. Let's carry on with this iGCSE 0607 paper 4. We are going to now look at question 4. So we have a typical GDC question here. So f of x is equal to x cubed minus 5x plus 3. We are given a scale here and we need to sketch it. This is the classic GDC question. So I am now going to open up my GDC. And I'm going to type that function in. So in the graph function here, we just press x cubed. Now the easiest way of doing this is clicking on this button here, giving you the index, and then you can put in the 3. There we go, minus 5x, and then we are going to go to plus 3. So we type that in, and you'll notice it doesn't quite look like what we need, because if we go back to our PowerPoint, you'll see the scale is given from minus 3 to 3 and from minus 10 to 15. So we need to go back to my GDC and we go to Menu, Window, Window Settings, and then we put in the correct settings. So I'm going to put minus 3 here. For here, I'm going to put 3, following the instructions of the question. And then we have minus 10 and positive 15. So you must change the window to fit the question that you are given. So we have our typical cubic shape here. Notice it crosses the x-axis 3 times, it crosses the y-axis once. So we're going to copy that across and make sure we have a good sketch. So let me get my pen ready. So it goes up, it crosses in the positive quadrant here, and then we go upwards like so. So there's a 2-mark question. I imagine the mark scheme would be looking for it crosses it 3 times, where 2 are in the positive and 1 in the negative, and it crosses here once as well. And now we need to find the coordinates of the local minimum point. So notice this is our minimum point here. So we are going to go straight back to our software. We are going to go to Menu. We go to Analyze Graph, and we're going to go to Minimum. And when we do this, we know the minimum's around here somewhere. We click before it, we click after it, and then we can read off the value for our minimum. Okay, notice that you are going to need both coordinates here, and we want to do both to 3 significant figures. So we have 1.29 and minus 1.30. So we write in 1.29 and minus 1.30. Always play on the safe side. Make sure you write this to 3 significant figures. Now, question C has been quite tricky for a number of students over the years, where they've tried to fit in or crowbar in this rotational symmetry into a GDC question. I've seen this now a couple of times, so be aware of this. Notice it's a 3-mark question, so we need 3 pieces of information, and we need to describe fully the symmetry of the diagram. The first thing we should recognize here is there is a rotational symmetry. Imagine this is our center of our rotation. It would spin around and actually look the same as we spin it around, and it will look the same twice. So we have to write down rotational symmetry, like so, for 1 mark. Order 2, because if you visualize this in your mind, you can rotate it around once when it's the same and then back to the beginning, so to give you twice. And we also need to know where the rotation point is. Well, this is going to be our y-intercept. Now we can actually, without using the GDC, actually read this off, because the y-intercept is always the number in our function. So this is actually going to be 3. So we just put in 0, 3 as our center. Again, 3 marks, they require 3 pieces of information. So make sure you do not leave anything out. Okay, and now we go on to part D. This is very, very typical for a GDC question, where they give you another function, in this case a straight line, and then you need to solve the equation. The amount of times I've seen people try to equate these 2 things together and then solve it, you simply can't do that with iGCSE methods, possibly with IB methods. So we need to use the GDC way of doing this. So let me show you very quickly how we do this. So if I go to our GDC, like so, we press the Tab button. This is a very useful shortcut. If you press the tab button, you can then type in the second function straight away. And let's remind myself, yep, it's 2x minus 1. So you go 2x minus 1, press enter, and you'll get a straight line that goes across like so. Now the question wants us to solve this. Notice you've got 3 marks, and that makes sense because you have 1, 2, and 3 intersection points. So we're going to work out these one at a time. So we go to Menu, Analyze Graph, and then we are going to go to Intersection, and we do it in the same way that we did it with minimum maximum. So we click before, we click after. You can just about see we scan this in, and we get minus 2.90. So we are going to type that in as our first part, minus 2.90. Notice we're looking to solve, so we only want the x values, okay? That's important to realize. Okay, and then we're going to do the same process for the other 2 points. So we go Menu, Analyze, Intersection. We click before, we click after, and this time we get 0.603. Again, be accurate with that 3 significant figures. So 0.603. Let's go back again. Almost therapeutic doing this. Menu, Analyze, and Intersection, and we click before, we click after, and we get 2.29. So go back to our PowerPoint and write in 2.29. Get 1 mark for each of these points. Now this is the part that is really that discriminator question between A and A star, so we need to be careful here. Use your answers in part 1 to solve f of x is greater than g of x. So if I was to do a quick look at my GDC, what we're looking for is when the function, the blue function, is bigger than the red function, okay? And we've already worked out the intersection points, and hopefully you agree here, the blue function is bigger than the red function between this point and this point, and after this point. Okay, so we're going to write that now in mathematical notation. So the way we do this is using inequality. So using the points that we just did, we have minus 2.90 is less than x. Let's be careful with the inequalities. Notice we've got a strict inequality here, not less than or equal to. So we know between these 2 values we just worked out that x, the function f of x, will be bigger than the red function that we had, but also, and this is what people forget, x is also bigger than 2.29. So you're using these values, and then you're saying to yourself, okay, when is the blue function bigger than the red function? Okay, I need to write this as an inequality. Okay, and this gives us the 2 marks, 1 for the first one and 1 for the second one. Before we move on, here is the mark scheme, so you can go through this yourself and then check what I've talked about here and look at where you score the marks. What's also important is that lovely examiner's report. So, question 4A, many good sketches were made, but just make sure to draw them carefully. Make sure that we have the correct degree of accuracy. Notice I was quite careful with that. 1.29 minus 1.30. A lot of people had problems with this in particular, not noticing that rotational symmetry fits into this topic, and also there are three facts that you need, including that center of rotation, which is really important. Okay, for part D, this is a bit more challenging. Again, make sure you write to 3 significant figures, and I think this inequality skill is getting better with our iGCSE students, but you still need to visualize it correctly. Okay, don't use algebraic methods as it says here. That is very, very important. And if you're liking the content that you're watching currently, then please do consider liking and subscribing and sharing with your friends as well. Okay, thank you. Okay, and on to question 5. So Naomi flies non-stop from London, England to Perth, Australia. Okay, it's quite a long way, I would say. The flight takes 16 hours and 45 minutes, and we're told the distance is 14,498 kilometers. And we need to find the average speed of the plane in kilometers per hour. And this is a clue in the question. So we'll need to convert this time into just purely hours. So we need to think here, okay, 45 minutes is in terms of decimal, how many hours? And then we think to ourselves, well, it's 45 out of 60, so that's 3/4, and so 3/4 is the same as 0.75 hours. This is really important to convert everything into one particular unit. At this point, we can then use our speed, distance, time triangle. So we have speed, time, and distance. We are looking for the average speed, so we're going to do distance divided by time. The distance is 14,498. We're going to divide by the time taken, which, as we've worked out here, is 16 hours, and then that 45 minutes is 0.75 of an hour. And now we just put this into our calculator. So we go to our calculator, 14498 divided by 16.75. Press the enter button and we get our time. Again, looking to round to 3 significant figures. I'm going to write out that decimal, so 865.552. Just in case in the exam you get the rounding wrong, you still can show that you've worked this out. And if we round this then to 3 significant figures, we then get the answer of 866. Okay, to 3 significant figures. Now, part B, I'm going to kind of do ugly. So the plane leaves London at 13:15. The time in Perth is 8 hours ahead of the time in London. Find the time in Perth when the plane lands. The way I tend to do this is I take my 13:15 and I add on the time that it takes. So it takes 16 hours and 45 minutes. So if I add this together, and just bear with me on this one, so 16 plus 13 is 29, and then add up the minutes together, I get an extra hour, so I essentially get 3000. Now we don't say this, of course, in terms of time, because time goes around every 24 hours. So in order to work out what time in the morning I get there, if I take away a full day, which is 2400, I then get to the answer of 6 a.m. in the morning, yep, also known as 0600. And now at this point, then I take into account the time difference. So time in Perth is 8 hours ahead, so we need to add on 8 hours, and that's going to get to the answer, well, 6 plus 8 is equal to 14, so we get there at 1400 hours. It's an interesting style of doing this question. I'm not sure if the mark scheme will agree with this kind of method, but I think this is a nice logical way of working through this. And for the last question, the cost in pounds of the flight is £827.75. The exchange rate is $1 is equal to 55 pence or 0.55 pounds. Calculate the cost of the flight in Aussie dollars. So my pupils, what they get confused with here is they know they need to times or divide, but they're often confused of exactly whether to times or divide. So the way I think about this is, we've got 2 choices here. You can times by 0.55 or divide by 0.55. We want this answer to be bigger because Australian dollars are worth less than pounds. So if we divide by a decimal less than 1, we'll get a bigger answer. Okay, so that gives me an indication of dividing. Now if I times this accidentally, I could check my answer and then think through it logically and go, that doesn't really make much sense. So if I pop this now into my calculator, I then get the answer of 1,505 Australian dollars. That makes sense because it should be bigger than 827 pounds. And we're done. Let's have a quick look at the mark scheme. So can you show you that? Okay, I don't think they did it the same way I did. Similar down here, but again, they'll take a lot of different methods there. Generally, this question was well answered, though, by the people that sat this last year. Yeah, some of the people did the conversion from hours to minutes, but didn't then work backwards afterwards. But majority did well on this question, so I'm not going to spend too much time going through this. Okay, and question 6. So it's typical sine cosine rule bearings question. So the diagram shows a field A, B, C, D, straight path from A to C, we can see here. The bearing of B from A is 75 degrees, we were given. Angle ADC is 90, also given. show that angle BAC is 31.6 degrees. Okay, so first of all, the angle BAC, B to A to C, so they are referring to this angle here. Okay, so we look at this question and then we have a think about what can we actually do to work this out. Well, we've got three sides here, 44, 62 and 95, and we're looking for an angle. That should trigger you, not in the modern way, but it should prompt you to actually use the cosine rule. Now, unfortunately, this one's not given on the formula sheet. The formula sheet gives you this, or an equivalent of it. C squared equals A squared plus B squared minus 2AB cos C. I get my students to actually learn off the angle version of this, which is cos C is equal to A squared plus B squared minus C squared over 2AB. Generally, I get my students to learn this because you don't be under stress to actually derive this from this equation. When you have three sides and you're looking for an angle, you can use the cosine rule directly. So, cos C is equal to, so this is our angle C, so this is going to be our small c, and then it doesn't matter which sides these are, A and B, but these two are really important. Cos C is equal to 44 squared plus 95 squared minus 62 squared, all over 2 times 44 times 95. Again, I would actually work out cos C individually, and then at that point I would then find the inverse of cos. So let's go back to my calculator and work this out. So we're going to want a fraction. We go 44 squared plus 95 squared minus, what was the value? 62 squared, all over 2 44 times 95. We're going to get an answer of some sort of fraction, that's fine. So I would press Control Enter if I want a decimal approximation, 0.851. This is worth writing down in case anything goes wrong. And then to work out C, well, what's the opposite of cosine? Well, that's going to be the inverse of cosine. So we do this, and we go back to our calculator. So we can go to trig, you'll see all the options are there, and then I can just actually select answer here, taking the previous answer, close bracket, enter, and we get our answer of 31.644. So let's go back, 644, which of course is correct to the answer given, 31.6 degrees. And we've got our 3 marks in the bag. I love those kind of questions where you can guarantee you've actually got the mark there. So let's write that angle in, because I'm sure we're going to need that in a future question. Let's have a look at part B. So now we need to find the bearing of D from A. The key thing about bearing questions, you're always working from right to left. So you start at A and you work your way around to D. So let's go back to the diagram. So the bearing of D from A. So watch carefully. So we start at A, at north line, and then we work our way around until we hit the line D. So in fact, what we're looking for here is this entire yellow angle. Now we've got quite a lot of this already. We've got the 31.6, we've got the 75. What we're missing here, let me do this in a slightly different color, is this small angle here. So if we can work out that small angle, then we can add all 3 answers together to give us our solution. Well, if we look at this particular triangle here, we have essentially a right angle triangle. This right angle is really important. We have 74 here, we've got 95 here, and we're looking for the top angle here. This should instantly say to you using SOHCAHTOA. So if we're going to use SOHCAHTOA on this, we need to label the sides. This is our adjacent side, this is our hypotenuse, because opposite the right angle. That means we are going to use the formula triangle of cos. We may not use formula triangles, but you'll see the next step is straightforward. So to work out the angle, I'm going to write it here and then go on the next slide. Cos theta or cos x is equal to adjacent over hypotenuse, 74 over 95. So let me write that on the next slide. I'll change the variable to x. Equals 74 over 95. So x is going to equal the inverse cosine of 74 over 95. And that's going to be equal to, let's check my calculator, that's cos of fraction, 74 over 95, enter, we get 38.8357. This is worth writing down. The answer again. Yeah, 83, dot, dot, dot. And so to work out our final answer, we add together 38.83, dot, 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 plus that previous answer of 31.6, dot, 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 plus 75. Now notice in the calculator, when I go back to my calculator, I'm actually going to use the unrounded values. So I'm going to put 75 plus 31.6449 plus 38.8357. This then gives me the correct answer. Now I did it this way to make sure there is no rounding error going on. So 145.481 dot, dot, dot. But generally they want this to three significant figures, so 145 degrees is going to be our total angle. Okay, even though this was a little bit overkill in terms of being accurate, you want to make sure you do not lose a mark due to a rounding error. So make sure you're aware of this. Okay, and now we're going to look at the shortest distance from B to AC. So let's go back. So from B to AC. One thing to be aware of, as soon as you see shortest distance, you need to be thinking a perpendicular line, i.e. a line that makes an angle of 90 degrees. Okay, it's also the same at IB as well on the applications course. So when we draw this line, BAC, if I draw this across, this by definition has to be a right angle. Okay, that's why you know it's the shortest distance. And once you've got a right angle, again, your life becomes a lot easier because you can then use SOHCAHTOA. So we are looking for from B to AC, so we're actually looking for this side, let's call it Y. We've got an angle, a side, we're looking for another side. So I would draw this out as a right angle triangle. We've got our 31.6. This is our right angle, this is what we're looking for. This is 44. We're going to use SOHCAHTOA. In this case, we've got the opposite and hypotenuse. Again, please pause the video if I'm going too fast. That's why we have the video. We're going to be using sine. So we're going to use the sine triangle. Sine theta times H and O. And we're looking for a side, so we're looking for the opposite, so we cross this out. We do this calculation. So our answer is going to be sine 31.6. You can use the rounded version because this was given in part A, times 44. And now we work that out on our calculator. So I can actually write sine on here and it becomes a sine function. Times, what was the value here? 44. And then we get to our answer rounded to three significant figures of 23.1. which we write in, 23.1 meters. And the last part is find the total area of the field ABCD. Okay, so essentially we've got a situation of two triangles. So there are different ways to go about doing this. I think the easiest way is to use this side y. So we've worked this out. Remember, the area of a triangle is equal to half base times height. So I'm going to label this 1 and 2. So I'm going to work out 1 first. The way we do that is do a half base times height. So let's write this in. So a half base times height. So we're going to do a half times the value we just worked out, 23.1 dot times, and then we want the base of the triangle which we have, which is 95. Okay, and then we're going to work that out. Let me put that on the GDC. So I can use the answer again, so 0.5 times, and it was 95, yep. That gives us 1095.13. I'm going to write down all those decimals, even though we're going to round to 3SF at the end. Now triangle 2, we can use a different formula for the area of a triangle. So we notice we worked out the angle here in a previous question. We worked that out as 38.83, so let me write that in. And notice we've got two sides and the included angle, which means we can use a half AB sine C, which is on your formula sheet. We then do a half times 74 times 95 times the sine of the angle, which is the 38.83 dot dot dot. We pop this into our calculator. Nice question this. So 0.5 times, yeah, 74, 95 times the sine of 38.83. Or you take the unrounded number if you've got a possibility. So you get 2204.22. So let's write that in. And then we just add those two answers together. So our answer is equal to 2204 dot 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 plus 1095 dot dot dot. And that's equal to what's going to come here. So the way I do this is go control answer. You can store as variables as well. 1095.13, and we get 3299.35. Let me just write that over here. But this is going to round to three significant figures of 3,300, which is our answer. So you can have a quick look at the mark scheme. So there's the mark scheme going through what I've just done here, and then the examiner's report. So generally it was reasonably well done. Okay, some people, yeah, used the longer method for part C, but again, spot that right angle triangle. That will make your life easier. Okay, and do use the half ABC sine formula as well. That will make it easier. You could have used Pythagoras on part D here, and then use half base times height, but my method with a half AB sine C will be much more efficient in the long run.